Hello everyone, myself Dilip Udani, and today I will teach you this topic, that is bitwise assignment, identity, membership operators and operators precedence. So let's start. First of all, we will see bitwise operators. The bitwise operators are given below. See, this is the AND operator. If both bits are 1, then only result is 1, otherwise result is 0. This is OR bitwise operator. If at least one bit is 1, then result is 1, otherwise result is 0. This is XOR bitwise operator. If bits are different, then only result is 1, otherwise result is 0. Now this is bitwise complement operator. It will change 1 to 0 and 0 to 1. Now this is bitwise left shift operator and this is bitwise right shift operator. We can apply these operators bitwise. How? I will just make you understand with the help of examples. These operators applicable only for int and boolean types. Just keep in mind, these operators are applicable for int and boolean types. By mistake, if we are trying to apply for any other type, then we will get error. For example, print 4 and 5. This is valid because here 4 and 5 both are int value. Then after print true and true. This is also valid. Why? Because we are applying bitwise operator on boolean type. Print of 10.5 and 5.6. This is not valid. It will give you the error, that is type error, unsupported operand types for AND, that is float and float. Now we will see how bitwise AND OR and XOR will work. Now what will be the output of this statement, that is print of 4 and 5. So the output in this case is 4. How? First of all, convert this decimal 4 into binary. Its equivalent binary is 100, and then after again convert this 5 into its equivalent binary, that is 101. Now apply the bitwise AND operator on this number as well as on this number. See, 0 and 1, it will give you 0 because any bit is 0, the result is 0. Now for 0 and 0, definitely the result is 0. Now for 1 and 1, see both are 1, so the result is 1. Any of the 1 is 0, the result is 0 in case of bitwise AND operator. So the output is 100 and its decimal equivalent is 4. So the output of this print statement is 4. Now print of 4 or 5. So the output in this case, that will be 5. How? First of all, you have to write down the binary equivalent of this 4, that is 100. Now binary equivalent of 5, that is 101. Now apply bitwise OR operations. 0 or 1, any of the result is 1, it will give you 1. Then after 0 or 0, both are 0, so the result is 0. Now 1 or 1, the result is 1 as both are 1. So the output is 101 and its decimal equivalent is 5. So the output of this print statement is 5. Now print of 4 XOR 5. What will be the result in this case? That is 1. See, just keep in mind how XOR works. If both the bits are different, then the result is 1. So first of all, what we will do, we will just write down the equivalent binary of 4, that is 100. Then after equivalent binary of 5, that is 101. Now 0 XOR 1, that is 1, as both are different bits. 0 XOR 0, the result is 0 as both bits are same. Then after 1 XOR 1, the result is 0 as both bits are same. So the output is 001. So the decimal equivalent of 001, that is 1. This is how bitwise AND, OR and XOR works. Now we will see bitwise complement operator, that is this one. We have to apply complement for total bits. How? I will just make you understand with the example. Print of complement of 5. So what will be the output in this case? That is -6. Now first of all, what we have to do, we have to write down the equivalent binary of this 5, that is this one. See, this is 101 and the remaining all bits will be 0. Now if you will apply the complement operator on these bits, so what will be the output in that case? You have to convert 1 to 0 and 0 to 1. See, this one will be converted to 0, this 0 will be converted to 1 and so on. Now as you can see, the leftmost bit is 1. So this is a negative number. To represent a negative number, we have to write down the number in 2's complement form. So how to find 2's complement form? For that purpose, you have to write down the 1's complement of this number, and then after you have to add the 1 to that particular result. Now the question is, how will you find out the 1's complement of this number? For that purpose, you have to replace 0 by 1 and 1 by 0. If you will replace 0 by 1 over here and 1 by 0 over here, and similarly if you will repeat the process for the remaining bits, you will get the 1's complement of this number. Then after add 1 to that particular result, you will get the 2's complement of this number, and its binary equivalent is 6. So the output of this print statement is -6. Now keep in mind the one important note, that is the most significant bit acts as a sign bit. 0 value represents positive number, whereas 1 represents negative number. Here if the most significant bit is 0, then it indicates a positive number, and if this bit is 1, then it indicates a negative number. Positive numbers will be represented directly in the memory, whereas the negative numbers will be represented indirectly in 2's complement form. And I have already discussed with you how to find out the 2's complement of a given number. Now we have left shift operator. After shifting, we have to fill the empty cells with 0. I will just make you understand this left shift operator with the help of example. Print of 10 less than 2. So what is the meaning of this 10 less than 2? We have to shift the 2 bits of the number 10 in the left direction by 2. So what will be the output? That is 40 in this case. How? I will just make you understand. First of all, what we will do, we will just write down the binary equivalent of decimal 10, that is this one, 0 0 0 0 1 0 1 0. Now what we have to do, we have to apply the left shift operator on these bits, and we will shift these bits by 2. So see, this 0 will be shifted by 2 position. So I will write down 0 over here, then after 1 over here, 0 over here, 1 over here, 0 over here, and 0 over here. See, if we will do in this way, then these 2 cells will be empty, and we will fill these empty cells by 0. Now if you will just find out the decimal equivalent of this binary number, you will find the value is 40. We have one shortcut technique for left shift operator also. If we have to shift decimal 10 by 1 bit in the left direction, so what will be the output in that case? We have to multiply 10 by 2 raised to 1. It will give you 20. Similarly, if I have to say shift decimal 10 by 2 bits in the left hand side direction, then what will be the output in that case? I need to multiply 10 by 2 raised to 2, that is 2 raised to 2 is 4, and multiply 4 by 10, you will get 40. In this way you can apply the shortcut technique also. Now we will see right shift operator. After shifting, we have to fill the empty cells with 0. Now I will just make you understand this concept with the help of example. Print 10 right shift operator 2. It means we have to shift the decimal 10 by 2 bits in the right hand side direction. So what will be the output in that case? That is 2. How I will just make you understand this with the help of example. First of all, we will write down the binary number of this 10 decimal number, that is this one. Now what we have to do, we have to shift 2 bits in the right hand side direction. If we will just shift these 8 bits by 2 positions to right hand side direction, so we have to discard these 2 places and we will be having 0 over here, 1 over here, 0 over here, this 0 will be over here, this one 0 will be over here, and finally this one will be 0 over here, and 2 places will be vacant, and we will fill these 2 vacant places by 0 0, and this is 0 multiplied by 2 raised to 0, 1 multiplied by 2 raised to 1. So this is nothing but the decimal 2. If we multiply 0 by 2 raised to 0, then after add the result to 1 multiplied by 2 raised to 1, you will get 2. So the decimal number of this binary equivalent number, that is 2. So in this case again we have a shortcut technique. What you have to do, if you have to say shift this 10 by one position in the right hand side direction, so what will be the output in that case? Divide 10 by 2 raised to 1, so you will get 5. And here we have to shift 10 by 2 bits towards right hand side. So what will be the output in that case? You have to divide 10 by 2 raised to 2. 2 raised to 2 is 4. So divide 10 by 4, that is 5 by 2. Divide 5 by 2, you will get 2.5, and consider only int value. So that is 2. So this is the shortcut technique to find out directly the result of right shift operators. We can apply bitwise operators for Boolean types also. For example, print of true and false. See, true means 1, false means 0. So 1 and 0. In case of AND operator, if any of the result is 0, that is false. Similarly, print of true or false. In case of bitwise OR operator, if any of the result is 1, the result is true. Now print of true X or false. In case of X or, if both are different, the result is true. Now print of true left shift operator by 2. So see, true means 1, and here we are shifting 1 by 2 bits in the left hand side direction. So multiply 1 by 2 raised to 2, that is 4. Now print of true right shift operator 2. So what will be the output in this case? True means 1. Now what we have to do? Divide 1 by 2 raised to 2. So 1 divided by 4, that is 0.25, and consider the int value, that is 0. So the output of this print statement, that is 0. Now we will see assignment operators. We can use assignment operator to assign value to the variable. C equal to is an assignment operator. For example, x equals to 10. Here we have assigned the value 10 to the variable x. We can combine assignment operators with some other operator to form compound assignment operator. How? I will just make you understand with the help of example. See, x plus equals to 10. So actually what is the meaning of this compound assignment operator? That is x equals to x plus 10. The following is a list of all possible compound assignment operators in Python. So this is the list of all compound assignment operators in Python. See, these are also compound assignment operators. Now for example, if I will assign 10 to x, and then after if I will just write down x plus equals to 20. So what is the meaning of x plus equals to 20? That is x equals to x plus 20. The value of x is 10 plus 20, so the output is 30. If I will write down print of x, so what will be the output? That is 30. 10 will be added to 20. Now we will see identity operators. we can use identity operators for address comparison. There are two identity operators, one is and other is not. R1 is R2 returns true if both R1 and R2 are pointing to the same object. R1 is not R2 returns true if both R1 and R2 are not pointing to the same object. How I will just make you understand with the help of one example. See, we have example here A and B both are pointing to the same object, that is 10 in this case. So print of A is B. So what will be the output in this case? As A and B both are pointing to the same object 10, its output is true. Now x equals to true, y equals to true. Again x and y are pointing to the same object true. So print of x is not y. So definitely this is not true. So in this case it will give us the output as false. Now keep in mind the important note, that is we can use is operator for address comparison, whereas this equal to operator for content comparison. Now we will see membership operators. We can use membership operators to check whether the given object present in the given collection or not. It may be string, list, set, tuple or dict. In returns true if the given object present in the specified collection. Not in returns true if the given object is not present in the specified collection. How I will just make you understand with the help of example. See, here is the example. X equals to hello, learning Python is very easy. So print of h in x. Now check whether h is present in this statement or not. Definitely yes. So the output of this print statement is true. Now print of d in x, whether this d is present in this statement or not. See, d is not present, so the output of this print statement, that is false. Now similarly check print of d not in x. Definitely d is absent in this statement, so the output is true. Print Python in x. So what will be the output in this case? Definitely Python is present in this statement, so the output is. Now we will see operator precedence. If multiple operators present, then which operator will be evaluated first is decided by operator precedence. For example, print of 3 plus 10 multiplied by 2. See, the operator precedence of the multiplication operator is higher than the addition operator. So first of all, 10 multiplied by 2 will be evaluated. Multiply 10 by 2, you will get 20. Then after add 20 to 3, you will get 23. Now print of into bracket 3 plus 10 star 2 or multiplied by 2. See, the precedence of the bracket is higher than the multiplication operator. So first of all, this bracket will be evaluated. Then after we will multiply the result by 2. So 3 plus 10, that is 13. Now multiply 13 by 2, you will get 26. This is how operator precedence works. The following list describes operator precedence in Python. That is first parenthesis, then after exponential operator, then after bitwise complement operator, unary minus operator, then after multiplication, division, modulo, float division, then after addition, subtraction, left and right shift, bitwise and bitwise XOR, then after bitwise OR, then after relational or comparison operators, then after assignment operators, then after identity operators, then after membership operators, then after logical NOT, then after logical and finally logical OR. You have to keep in mind this operator precedence. So this is the example of operator precedence. A equals to 30, B equals to 20, C equals to 10, D equals to 5. Now what will be the output of this print statement? First of all, A plus B bracket will be evaluated. 30 plus 20, that is 50. Then after C slash D will be evaluated. 10 divided by 5, that is 2.0. Now multiply 50 by 2.0, you will get 100.0. Now similarly for this print statement, these brackets will be evaluated first. A plus B, 30 plus 20, that is 50. C by D, 10 by 5, that is 2.0. Now multiply 50 by 2.0, the answer is 100.0. Finally print of A plus B star C slash D. So first of all, B into C will be evaluated, then divide the result by D, and then after we have to add the result to A. So B into C, 20 into 10, that is 200. Now divide 200 by 5, it will give you 40. Now add 40 to A, that is 30. So 40 plus 30, that is 70.0. This is how operator precedence work. So in today's lecture, we have seen bitwise operators, assignment operators, identity operators, membership operators, and finally we have gone through operator precedence. And we have seen various examples based on these topics. Thank you for watching this video.